So my name is Daniel Bohannon, and today I will be talking about PowerShell obfuscation techniques and how to try to detect them. Just a little bit about me. This is what I normally look like. I lost my razor on the plane, and this is what happened. But this is typically what I like to look like on the internet, so keep a low profile elsewhere. This is my Twitter handle as well as my personal blog where I talk about PowerShell stuff. A little bit about me. So for the past year and a half, I have been an incident response consultant with Mandiant based out of Washington, D.C. Prior to that, I spent 5 years doing operations and security for a national restaurant franchise based out of the U.S. Throughout this talk, I just like to remind everyone that I am a blue teamer. I did not set out to develop a red team tool, although the red teamers in my organization like what I've done here. Ultimately, as a blue teamer, I want to push the bounds of what is possible in PowerShell attacks, and so that we as defenders collectively can do a better job at knowing what's out there and how can we detect without making dangerous assumptions. That's exactly what we'll look at today. There's a lot of content to cover, so there's not going to be a lot of fun pictures. There's a couple sprinkled at the end, something to look forward to. But just hold on tight. All of the slides will be published, talk will be published, and I'll be around all day today, and I can talk for as long as anyone is interested about PowerShell, and I'm really excited about the things that I want to learn from everyone in this room as well. A lot of great minds here, so I'm really excited about that. So, a motivation. Why did I start doing this research on PowerShell about a year ago? After that, we're going to look at basically a single slide on preparing your environment for PowerShell attacks. Much easier said than done. Then we're going to look at an in-depth obfuscation example, obfuscating what typically is called the remote download cradle in PowerShell. Then we're going to look at additional methods for remotely downloading, just from a richness of PowerShell as a language, then more obfuscation techniques on top of that, and then how we can try to detect those techniques. Then we're going to look at some encoding and decoding fun, looking at some common mechanisms as well as some uncommon mechanisms that we've yet to see attackers use. Last, we'll look at what I like to call launch techniques, and then we'll do a quick demonstration of a tool that I wrote called Invoke obfuscation. This is open source. It's on my GitHub. Links will be at the end of the slides. So let's get started. My motivation, again, I'm a blue teamer. My job is to detect evil. And so I really started to wonder, okay, well, most of the investigations that our team performs, PowerShell is used at some point in the attack. As investigators, how are we detecting PowerShell? So I started to look internally at our own techniques for looking at PowerShell, started to look at what our competitors were doing, what are people in the industry doing to detect PowerShell, because it just really is so prevalent in attacks. We see PowerShell being launched in a lot of interesting places, registry, file, macros, remotely, all over the place. And so at the end of the day, the consensus that I found was most people are detecting malicious PowerShell looking at command line arguments for PowerShell.exe. And hopefully by the end of this talk, you'll see why that's not quite as simple as it may seem, and there's a lot of bad assumptions even just in that. So the current state of detection. The two biggest things that we see attackers using in PowerShell are encoded command, which is a base64 encoded command, and then this new object net.client web client download string, which is again the most common remote download syntax, which allows you to download a script in the memory, execute it in memory, no file hits disk. However, for both of these, this is not the only way to write these functions, and it's also not the only way to perform the functionality behind that function. So the importance of knowing your options is huge here. So what I started to do is, starting with these examples, I started to just kind of in a small research bubble start to syntactically look at what are other ways we can write these functions that break our current detection. And as I found ways that broke our detection, I then upgraded our detection to catch that. And so kind of this cat and mouse game began to go on, and really it's been the most fun thing I've worked on for the past year is doing just this and building out our detection to look for obfuscated PowerShell commands as well as alternate syntaxes to perform encoding, decoding, and remote download functionality in PowerShell. And most of these techniques were found kind of in a bubble, and also reading other people's approaches in forums and blogs and stuff of that nature. But as we started to find these techniques, we actually started to see attackers using some of the simpler techniques and a couple of the more complex ones. But most of what we're talking about today are things that we haven't yet seen attackers use. But I attribute that mostly to most people don't have any visibility into what's happening in PowerShell in their environments. And my hope is that at the end of this talk that people will have more of a motivation to see why certain changes should be made in your environment to make detecting PowerShell attacks a lot easier easier proactively as well as retroactively going back and seeing what exactly happened. So my goal, my hope for the blue team is that your awareness will be raised and that detection will change for you and your clients or your organizations. For the red team, I hope that you find these techniques to help you be more successful in your engagements. Ultimately, hopefully benefiting the organization, the target, so that they can learn from these attacks and better defend against them. And then lastly, one of my hopes is that the tool, Invoke Obfuscation, will help people to be able to very quickly implement all these techniques in a randomized fashion so that you can easily benefit from this research and test your own detection capabilities. So, preparing your environment. This is probably the hardest slide in the entire talk because it's easy to say, very difficult to do. At the end of the day, if you want to detect malicious PowerShell, for the most part, what you would at least like to have as a bare minimum is command line arguments. If you don't have this, I really feel for you. But you can have this in event logs. So if you have your 4688 upgraded event logs, you'll have process arguments as well as parent process arguments. Also, you can install sysinternal sysmon. EID1 will give you very similar information and a bit more. Or if you have some kind of real-time agent that can basically monitor event log or monitor process command line arguments, or something open source like Uproot IDS can do the same thing. In addition, that's the bare minimum. The PowerShell team at Microsoft has developed fantastic logs available starting in PowerShell version 3 and in much, much better logs available in 5, many of which have been backported into 4. These logs are superb. However, you have to keep in mind, I'm not going to say what their limitation is, but when we go through these examples, you'll see that some of these obfuscation techniques actually do persist into those logs. So what I like to say is at the end of the day, if you have command line arguments, if you have all the PowerShell logging enabled and you're actually looking at it, all the information is there. It's just not all in any one place. So let's look at an example. The remote download cradle. We see attackers using this all the time. And well, it's really because it's what people know. It's what they talk about. It's easy. It's what's copied and pasted in forums. It's what popular tools output when you're looking for PowerShell commands. So let's play a little cat and mouse game. We have a red team command at the top, which is remotely downloading this bit.ly link, which is totally legit, I promise. And then it invokes what comes back so that it's run entirely in memory. So on the bottom, we're going to start to build as a blue team, build some detection rules to look for this syntax. So if we have a rule and say, okay, if I see PowerShell run and the arguments contain invoke expression, new object, system.net.web client, and .download string HTTP, then this would catch this, right? It would catch this exact syntax correct, but let's start to see how can we obfuscate this at a pure syntactical level to bypass our detection. And as we bypass our detection, we'll adjust our detection to make sure we're catching it, to try to find the lowest common denominator that we can accurately detect this activity. So first, whenever you see system dot in PowerShell, it's referencing a .NET class underneath. System dot will automatically be prepended, so you don't actually have to specify system dot. Most people don't, but sometimes you'll see tools that generate that. So we'll remove that from our attacker command. We'll remove it from our detection. Next, the URL. This is a string. We can concatenate this in line. We can set it as variables. We can do all sorts of things. So we're going to remove HTTP from our detection down there. You can use single quotes. You can insert white space there. So we'll just go ahead and remove that double quote from the detection as well. All right, keep going. Download string. This is a member argument for the net.web client class. However, it's not the only option. You have download string, data, and file, and then you have async and task async to go onto any of those. String is the most common one because it downloads an expression into memory. Download data also downloads into memory, but it's actually a byte stream, so you have to convert it. We've seen attackers use that before. A lot of commodity malware will use download file to hit disk. So why don't we just get rid of the string part and just say we'll look for .download for our indicator. So we'll catch all those options. The parenthesis, this doesn't necessarily have to be there. Some tools will set new object net.web client as a variable, typically calling it WC, and then you can just have variable .download string. So let's remove that parenthesis from our trigger. So how could the .download be problematic? Well, because I'm very stubborn and I like to bang away at this from a syntactic perspective and see, can I put this here? Can I put this? Can I move this around? I found that with a member, you can actually put single quotes around it. So now .download isn't even necessarily reliable. We have to just stick with download, which is a little bit less of an attractive, trigger string. But then I also found you can put double quotes around it. And I want you to look really carefully at download string because I promise you this next slide, this actually works. I put a tick mark before the L. Now, why does this work? Well, the tick mark is the escape character in PowerShell. Typically, you'll see it before a 0 for null, or before these other seven lowercase characters to do like new line or something like that. When you ever have a long line in PowerShell, you can actually wrap it on multiple lines by ending the line in a tick. That's because it is escaping the implied new line character that's there. So if you put a tick in front of something that doesn't have any special meaning, it's totally cool with it and runs. Now, why does this matter as a defender? Well, we can put ticks in front of all the characters that aren't these special characters. And actually, if we uppercase those special characters, it works. So now we can put tick marks in front of any character we want in a member argument when it's wrapped in double quotes. And this is important because they persist in the command line arguments as well as PowerShell script block logging, which should kind of be the source of truth of what's being executed, right? And it technically is. However, it will basically show you, script block logs will show you every layer of deobfuscation or decryption that is being passed into an invoke function. However, at this layer, we're not passing any of this into an invoke function. It is the command itself. So you can see our ticks are still there, our concatenation, white space, it's all there in both command line arguments and script block logging. So we can regex all the things and try to catch all these possibilities of tick marks, which I initially thought was probably a good idea. Quickly found out it's not a great idea. So we're just going to scratch this as an indicator. If you did try to go the regex route, keep in mind that in addition to download string, file, and data, you also have open read, which is similar in that it gets a byte array or a byte stream, and we've seen one attacker use this before as well. In addition, and this is why I wouldn't go the regex route for member arguments, you can actually, this is a little different in PowerShell 2 versus 3 and later, but there's two different ways where you can basically treat a member argument as a string, and now you can start to do inline concatenation or even like reordering of that string with something like the -f format operator such that you never actually see download string anywhere. Because some folks will use the approach of, let me just remove special characters from the command line arguments and then look at what's left, and this will completely bite you if you just rely on that because you can start to reorder essentially any component of a PowerShell command as a string, and then it never shows up like you'd expect it to. But it still works. So let's just remove that download as an indicator. Next, net web client. This is an argument to the command new object. This one's really easy. We can do double quotes and ticks. We can do treat it as a string if we wrap it in parentheses, or we can set it as multiple variables, chop it up in little pieces. We're good to go. So we'll just go with the first option. Throw some ticks in there. Get rid of that as an indicator. New object. Now, PowerShell, again, is such a robust language. There's so many options. And a lot of times for commands, you'll have a lot of aliases, shortened ways to basically say the same thing. So when I looked at new object, I thought, well, this is great. There's no aliases for this. This should actually be a pretty good indicator. But it's not. And there's a reason because, there's so many options in PowerShell. Sometimes you'll forget what commands are available. So you have this nice thing called get command. So let's say, okay, I know that I have a command that's new-p something. So let me just do a get command on new-p wildcard, and it shows you all the commands that are at your disposal. As with everything in PowerShell, really, it's not returning text. Those are actual PowerShell objects being returned. And what that means is that if I can return a single object, I can actually then invoke that object. So I have get command new object, and that's returning a single object, and then I can invoke that object, and it's the same as calling new object in and of itself. In addition, we can do invoke expression on that object, or we can use the ampersand or the dot invoke operators. Now the next piece is where it gets really fun. Remember those wildcards? That's new object. Every single one of these, as long as you're returning a single object, is now new object. So if you're looking for the string new object on the command line or in script block logging, you're going to see that. In addition, get command has an alias of GCM. It also has an alias of command. This is not documented. Why does command work? Well, PowerShell will automatically prepend a get dash to whatever you type to say, hey, is this an alias? There's an order of operations that it goes through. So now command actually resolves to get command. And if you start triggering off of anytime you see an ampersand or a period or the word command in arguments, you're going to get a lot of false positives because a lot of these start to take on meanings in different places. For example, a dash command is actually a legitimate execution argument in PowerShell, still on the command line. So if you're starting to build out regex looking for some of these terms, you need to take that into account. You're going to get a lot of false positives, I know from a lot of false positive experience. In addition, we can, for get command, instead of using asterisk, we can set the commandlet name as a string and use variables or whatever else we want. Again, trying to figure out how can we break up this information into as many little pieces as possible so it's more difficult to assemble if someone's manually looking at it, but the main reason is so we can get around current detections. Again, if I know as an organization that you're looking for a new object, I can totally get around that by using these techniques. And as defenders, this should be startling to see, but it should also give you an awareness of what things you need to start looking for and shifting, not just from looking for known bad, but also looking for what I like to call indicators of obfuscation, looking for weird stuff like this, and it gets weirder. In addition, with PowerShell 1.0, if you look at poshcode.org, there's some great stuff out there with PowerShell 1.0 syntax that I've really not seen any attackers using to this point, but there are some really interesting advantages, especially for red teams from a logging perspective, if you can find ways to accomplish your task, either calling .NET directly or using PowerShell 1.0 syntax. So in this, we're using PowerShell 1.0 to do get commandlet. If you're not looking for execution context, that weird variable, there's a lot of crazy stuff you can do with that that most people aren't aware of or looking for. In addition, you can do get commands, get commandlets, or a combination of those to be able to use wildcards. And again, this is all on the slides, so I'm just quickly going through some of these examples. We'll just go with the first one, the GCM. So now that's a new object. We can do the same thing with get alias, alias or gal, although instead of dealing with the full object or command name, you're dealing just with the alias name, but works just the same. And for all these examples, if you look at PowerShell module logs, it will show the correct parameter binding of this. So it'll actually eventually show new object is called with an argument of net.webclient, and it will remove that obfuscation and show you that as well. So again, when I said earlier, all the evidence is there, it's just spread across different places. And as an attacker, if I can put that information in different places and make it harder to have any one event log you can key off of, then that's good for an attacker. As a defender, we just need to be aware that's possible. We're not placing all of our defensive eggs in any single basket. You can also just put ticks in front of any of these commandlets. You don't have to put quotes around it. In addition, there's this great little thing called splatting. So now I can use, again, our friendly invoke operators, ampersand or dot, and treat the commandlet as a string. So we can either try to regex all of that we just covered, or we can just remove new object as an indicator. So we'll just do that. So we're left with invoke expression, which is actually a really, really good indicator in and of itself. If you see IAX or invoke expression on the command line, that's something worth looking into. However, what's potentially problematic about invoke expression? Well, we have the alias, IEX. Ordering also isn't important. You can have it before or after the expression. You can put tick marks just like you can with any command. You can do splatting, which now you're breaking it up into string objects, which you can then reorder those. And then you have kind of the cousin of invoke expression, which is this thing called invoke command. Now, typically you'll see invoke command used to say, I want to run this command on this remote system, but if you don't specify another system name, it executes locally. The biggest difference is that invoke expression is expecting a string or an expression, but invoke command is expecting a script block. And it has a lot of options. We have invoke command, ICM, dot invoke, or again, ampersand or dot. So if we're trying to piece all this together into our alerting trigger, how would we expect to really not get a ton of false positives if we're looking for a dot or an ampersand? That's crazy, right? Well, if we know that it's associated with a script block, we could say, okay, we can try to pair that with curly braces, but as we'll see, that's not always the case. Again, with PowerShell 1.0, we have this nice syntax, invoke command, invoke script, which will actually work on an expression or a script block, something else to be looking for. We can add in ticks to any of these. So again, I said if we're trying to reduce false positives for the ampersand of the dot by looking for braces, which again typically is what you'd see denoting a script block, not the case. We can convert expressions or strings to script blocks using .NET syntax or once again PowerShell 1.0 syntax. I know this is small, but again, it's in the slides, so you can go back and look at this and say, are we actually looking for these methods being used, especially on the command line? And for any of these syntaxes, we can obfuscate them. And what you'll find is that when you do this, the whole command we just worked to obfuscate is now a string object, which is this red expression, which means that we can, after we obfuscate all the tokens of a command, we can then take that command, treat it as a string, and now like a layer 2 perspective, do any string manipulation on that command. And once we look at the tool demonstration, you'll see how you can basically start to stack all these layers on top of one another and just build this garbled mess that eventually comes down into the original command, but makes it very, very difficult to detect unless you're looking for these indicators of obfuscation. Here's just an example of obfuscating the .NET command. Those are in the slides for your pleasure later. So we'll just go with the 1.0 syntax for invoke expression. So this is our command now. So unless we're wanting to do just insane regex, which computationally is really going to suck if you start to do regex on some of this stuff, then that's going to be really frustrating. And this is just one example. This is just looking at net.webclient for this remote download functionality, but what other options exist? So let's look at some additional methods. So again, we looked at this basic one, which is mostly what we see attackers using. With PowerShell 3 and later, we have invoke web requests and invoke REST method. Not PowerShell 3, any version going back, we have these .NET methods. And again, that system dot isn't really necessary. So we actually have seen some attackers use some of this where basically you have to treat the byte stream back into an expression before you invoke it. But it's being used out there and a lot quieter in the PowerShell logs. So again, if you can do something in .NET directly, then it's maybe not going to actually show up in PowerShell logs at all. So. But what if we're an organization and we feel really confident in our regex and we're looking for all this stuff and we're finding all this stuff we just talked about. And on top of that, we realize in our own humility that there's probably ways that we don't know about that can be used that would bypass our best efforts at detecting. So what if we said, okay, well, why don't we just look for any time that PowerShell.exe makes a network connection? You can do something like that with sysmon, EID3. It basically binds a network connection with the binary that causes that connection. So as a nefarious attacker, what if we opened up Notepad? And what if we went to open a file, but instead of a file name, we typed in a URL to something like, I don't know, invoke mimikatz. And we hit enter. Notepad actually fetches the remote contents. So this got me thinking, how can we automate this process with PowerShell? And there's a great little class, .NET class called SendKeys. Allows you to interact interactively with an application or anything you want. So this code opens up Notepad, sets it as the active application, then sends a Control-O to go to the open prompt, and then types in the URL of whatever you want, hits enter, waits a second, and then it sends a Control-A to select all or Control-C to copy all, and the last bit of the command back in PowerShell rips the contents out of the clipboard and invokes it, and PowerShell never makes a network connection. Notepad does. So this totally bypasses our detection if we're only looking for PowerShell making network connections. Now, in this example, we use SendKeys. The top, these both do the same thing. The top is using PowerShell syntax to do this. The bottom is using .NET. And if you can manage to get a void, those void strings in front of a .NET, you're going to be golden, silent when it comes to PowerShell logs. So again, if you're an attacker, then it's really helpful to think, whenever PowerShell makes something easier for you, it typically is also gaining additional visibility for the blue team. So if you can not take the easy road, you can do some really cool stuff. As a defender, why does this matter? We need to be looking for all this. This is all important to us, not just one or the other. And this really works with any application with an open file GUI functionality. POCs for all of those. However, it's actually not entirely in memory. When you do this kind of weird stuff, a file actually does temporarily hit disk and temporary internet files. Here's some examples here. Most of the time it retains the original file name. With Excel it doesn't. But there's some other quirky things that change with these applications for like opening recent files from remote locations. So from a forensics perspective, there's actually really interesting pieces of evidence we can look for if these applications are used nefariously in this way. So SendKeys is kind of a fun, but really a sloppy example, right? Most users, hopefully, if they see Notepad popping up, then they'll call someone up and be like, hey, something strange is happening with my computer. So I think the more dangerous thing to be looking for is PowerShell's interaction with COM objects. Here's an example of PowerShell using a COM object to say, hey, let me spawn an Internet Explorer process that actually isn't even spawned by PowerShell.exe. Something to think about. Spawn by another process, and let me interact with it silently, so it's not just minimized, it's completely hidden from the user, and make Internet Explorer go fetch my content, and then I can parse out of the HTML whatever elements I want to invoke as an expression. Looking for Notepad making internet connections, that should be really weird, right? Like a big no-no. What about Internet Explorer making internet connections? That's his whole job. That is normal MO for Internet Explorer. In addition, this will use the default user agent string for that user. So this is a really nice and clean method in my opinion. So again, as defenders, are we looking for PowerShell doing COM object interactions? So more obfuscation techniques and detection attempts. I'm going to super fast go through these. But basically, remember I said if you can take your entire command and treat it as a string, you have tons of options to basically manipulate it at a string level. So you can do stuff like reversing your command. So now if you're looking for a new object, the whole thing is in reverse. Or inserting garbage delimiters and splitting it before you invoke it, or replacing those delimiters before you invoke it, or concatenating it in weird ways before you invoke it, just to mess with what appears on the command line arguments as well as what's in script block logging, but it still works. So how can we detect some of these techniques? Well, we can start looking for some of these string manipulation functions. And again, there's so many ways to do this. You have PowerShell's manipulation functions, you have .NET's manipulation functions, but there's actually there's a lot of false positives that can come with this because there's some legitimate stuff that uses this. But again, if you're doing a single organization, then absolutely you should be looking for these. But like for us, when we're trying to scale to all of our clients at the same time, it becomes a bit trickier. So we have to be a little bit more specific about what we're looking for. You can look for high counts of certain characters. Again, like in the earlier examples, like how many tick marks would you legitimately expect to show up on the command line for PowerShell? Like probably not 50. But you know, there could be some cases where you'd have some, but something to look for. Just keep in mind that with any of these techniques, there are always ways around it. And in addition, if as an attacker, if I know that this organization, my target, is looking for certain high counts of characters, I can just do a ASCII char conversion on the fly so that my character, in this case, string char 59 is a semicolon. So now I just put in delimiters in my command, and this is what shows up on the command line. And then in memory, I replace those delimiters with whatever characters I want so that it works from a functionality perspective, but that character never shows up at all. So as a defender, am I looking for string cast, for char cast on the command line? How often should that be the case? Token type obfuscation, you can do this a little bit differently in PowerShell 2 versus 3 and later, or you can do what's called direct type casting, which is something that I just added to Invoke obfuscation in yesterday's, or 2 days ago in the release. So, encoding, decoding, getting close. So what are attackers actually using to obfuscate their code? Typically just encoded command, because PowerShell gives it to them. You'll typically see these flags like not, nani, null, stuff like that, and these are the common syntaxes you'll see with that. There's a lot of ways where you can basically accomplish the same task by changing a registry key. A lot of commodity malware is starting to do this, where instead of, as defenders, if you're looking for execution policy bypass, then if, as an attacker, you just change that registry key before you launch PowerShell, you don't have to specify that. So window style is another one where attackers will do that. They'll basically change where you want the PowerShell window to show up, maybe, I don't know, 1 pixel by 1 pixel way out in left field. That way you don't have to define it on the command line. So encoded command. This is typically what we've seen attackers use. Encoded command, encoded ENC. And as I started to play with certain tools, I saw they were using -E, like Metasploit uses -E, and it's like, this isn't documented, but it works. Why? It just kind of confused me for a bit. So as an attacker, or as a defender, if we basically look for these indicators, would we catch all these examples of encoded command? Well, yeah, we would. We're looking for, again, white space, dash encoded command, white space. That would catch that, right? However, these aren't all the options. So PowerShell gives us EC for short and encoded command, but they also give us that. Every single one of these works, all the way down to -E, because PowerShell auto-appends an asterisk to the end. So as long as the parameter for the function you're calling is specified just long enough to return a single parameter, you're good to go. That's why you have not, nani, and null, because that's the shortest string it takes to return only that one flag. So this is terrible for defenders because this means that all of our assumptions we just made about catching these flags is completely shattered if we're counting on white space being after the end of those flags. A side note on this, in Invoke obfuscation, when you're building your launchers, when you select whatever these flags you want, what I've done in the tool is basically I will randomly choose any substring in the valid range of each of those arguments. I will then randomize the order of those arguments and then insert random white space between them. And it's not just to be mean or cruel, but it's because a lot of people have built detections based off of very specific spacing, as well as forms of those encoded command flags and stuff like that. Even a lot of AV vendors do that. And it's bound to fail because it's super easy to change. So I just want to go ahead and break that habit with this tool and show you have to be aware of the possibilities of the ranges of these flags and build better detection based on those possibilities. So that's using encoded command. There's also the .NET base64 methods, which, again, a lot of tools use this as well. So are we looking for convert from base64 string? If we're not, it's a really good indicator to look for. But what about some different ways of encoding? We've actually seen, if you use Cobalt Strike, you'll see they use bitwise XOR quite a bit. But what about ASCII or hex or octal or binary? These all would totally work, and I put them in the tool because they work, but I haven't seen them being used before. But again, if as defenders we're relying on looking at certain base 64 encoded strings, this will break it. So are we looking for ways that we can basically convert ASCII values into hex or binary? And there's a ton of different functions to do that. And as with every other element of the Invoke obfuscation tool, every syntax I found that works, I've included that into the tool, and it will randomly choose one of those options for every element of every command every time you run the tool, so that you will never get the same output twice. And again, it's not to be mean, it's to show that it is possible, and we have to be aware of all those options as defenders when we're looking for it. Otherwise, we're going to get burned. So what about a different way of encoding with PowerShell? I got to looking at this earlier this year. I said, well, PowerShell, when you're done with passwords, has this great thing called secure string, right? And does anyone recognize this command? Oh, wait, as secure string. you know the whole asterisk wildcard thing, so it resolves to as secure string. So anyways, what this is doing is basically reading in a password and storing it as a secure string object. You can then convert it from a secure string object into this plain text. And if you don't specify a key, then it uses the user name and the computer name for the keys, which is using DP API. However, this makes it such that, hopefully as a password I have on my system, you can't easily run it on your system. But if I specify a key, then it can work on any system that has that same key. So the size limit on secure string is 65,000 characters. I feel pretty good about my passwords, but I've never felt like 65,000 character good about my passwords. Like, why is it so big? And when I saw that, it got me thinking, what if I put like an entire script in a PowerShell secure string password object? So that's what I did. And when you do this, this is actually just putting a very small command, but you can see the considerable bloat that comes from this. So secure string encoding, actually technically it's encryption, it's AES encryption, 16, 24, 32-bit, depending on the size of the key that you use. This is in the tool, and yeah, it's a lot of fun. It will bloat considerably, so I'd use this one with caution. This is what it looks like on the target system. And again, in the tool, there's three different, two .NET versions and one PowerShell version. The syntax of actually extracting the command, which is really, or the password, which is really a command or a script, into memory before you invoke it. So if you have like a really large script, like invoke Mimikatz, it's going to take a really long time to decrypt that, and your CPU is going to spike. It's going to take like 30 seconds. So for that, what I do is I just chop it up in a lot of little pieces, secure string each object with a delimiter, post it somewhere like on pastebin, and then pull it down in memory, and and basically split on the delimiter for each secure string object, unsecure string it, build out my full command when it's all there. I then execute the full command, and it takes 1 second. So after I finished this POC, I was trolling around on TechNet and found this guy who said, hey, this was like back in 2010, is there an obfuscator for PowerShell? And this person says, I guess you could put something in secure string and then pull it out and invoke it. And I was like, ah, dang it. I thought I had something kind of original. And so I talked to my boss. I said, hey, like, I just finished this POC. I think it's pretty cool, but this other guy, I feel like kind of deserves the credit because he came up with it first. And my boss was like, dude, the guy got 0 upvotes. You're good, man. But it ends up the guy is this Just Carl rock star on TechNet. So kudos to him for having that insight several years ago. But again, I still think it's a cool POC, and it's in the tool to make it really easy to test. Lastly, launch techniques. What I'm not going to talk about here is unmanaged PowerShell, calling PowerShell without PowerShell.exe. Other folks like Ben 10 have covered that a lot better than me. There's other talks out there, something to be aware of. I'm talking about weird ways to launch PowerShell.exe such that you can abstract the arguments from ever showing up in PowerShell.exe's arguments. So PowerShell, you can specify dash command, or you can just use a dash for standard input. So what this looks like right here, you can also use the input variable, is that we're echoing our command into PowerShell, so that the arguments, command line arguments for PowerShell don't actually show the command at all. They're in the parent process. So as defenders, are we looking for all these things we just looked at? Are we looking for these in other processes besides PowerShell? And it's a lot bigger problem than just command. We can do the same thing by setting our command in an environment variable, then spawning PowerShell to hit that variable. Commodity malware, like Kofter, does this. We're seeing this quite a bit already. I'm going to keep going. You can do the same thing with a clipboard. Just have, pipe it into clip and then spawn a PowerShell process to rip the contents out of the clipboard and execute it. The actual command is in the parent process. So does this mean we can just look for all this stuff in PowerShell or the parent process and we'll be good? No, not quite. What you can actually do is, let's say we're going to introduce a third process. We have command PowerShell. If we run this command, it actually works, but the parent process still has the command. What we have to do is actually escape that pipe, one layer of escaping. So it is escaped for the first command, but not for the second one. And when we do this, PowerShell doesn't have the arguments, the parent process doesn't have the arguments, the grandparent does. And there's nothing stopping you from pushing this even further. In the launcher section of my tool, I have all these techniques there at a simple push of a button, so you can actually build out the syntax on the fly just like that, handles all the escaping, and you can run it to see, are we able to detect this kind of stuff? And here's what it looks like kind of from an outline structure of that command. You also have crazier things where you have completely unrelated processes. Again, think about the clipboard example. You can have this process over here. You have your parent process spawn this command to echo into a clipboard, then spawn another PowerShell process to call the contents of the clipboard. And if you see this PowerShell syntax running, you recursively look for the parent, you'll never actually find the command right here. And this example is actually using WMI. We have seen an attacker use this, where they're basically spraying their command into several different processes, into the arguments, and then spawn an unrelated PowerShell process to use WMI, query out the command line arguments, piece it back together, and then execute it. Crazy. Ready for a demo? So my disclaimer is, please don't use this for evil. Again, I'm a blue teamer. I really hope this helps the blue team, and I hope that responsible red teamers would find this tool useful as well. So again, this is live on GitHub. I have version 1.3, which I'm pushing right after this talk, specifically for Hacktivity, which actually introduces 2 new launch types, which are clipboard for the parent process and clipboard for the grandparent process. So be on the lookout for that. But basically, you just import the module and run Invoke Obfuscation. I really like ASCII art a lot. So I do a little animated ASCII art there. So here's the main page, and we have a menu. Everything's color-coded because I'm OCD, and hopefully that's fun for other people. And so basically, options in yellow will take you to another menu or another prompt, and options in green will actually apply obfuscation or apply something to the payload that you have. So the first thing, we'll just go to tutorial. We actually need to set our payload, and you can do set script block or set script path, and that can be a local path or even a remote location if you want to download an entire script. So again, all these obfuscation techniques work for both a PowerShell command as well as an entire script if you want. The bigger the script, it's going to take a little bit because every element that's possible to randomize that I've found is randomized. So performance isn't the key here when you're building the commands. It's all about introducing as much randomization as possible. So we've set our command. We can also use to navigate the prompts, which we have at the bottom, our token string encoding launcher. We have back cd ... We can use home main to go to the beginning. But in this example, we're going to go to the encoding menu and apply option number 5. Remember, green actually applies obfuscation. So here's our secure string. There's the output. So let's go back to the tutorial. We can at any time run test or exec if we want to actually invoke what we currently have. You may not always want to do this, but just for simple examples like this, it's nice to see, yeah, this command still works. Show will show you all the information about the original command, the obfuscated command, and all the obfuscation steps you've taken up to that point. Copy or clip, bring it out to the clipboard. Out, you can specify a file path to get to disk. And as we see, if we do show options, again, there's all the obfuscation we've applied up to this point. The length as well, if you're wanting to put this on command. If you ever exceed the 9,000 something limit, it'll tell you, hey, you've exceeded this. If you want to put this on the command prompt, it's not going to work. So you may want to reset. So reset removes obfuscation from the current command to let you go a little deeper. So this was just a simple tutorial. So let's go and actually use the invoke, or use the remote download cradle and have a little fun with that. So the first thing we'll do is go into token. All right, and this is following the order of the talk we just looked at. So first we'll look at how we obfuscate from a syntactical level all the tokens of the command. So first we'll look at string. So the URL is a string object. So if we type string, we'll then see we have just one option for here, just to concatenate in line. So we type 1, now our URL is concatenated. So we'll go back, we'll look at the next token, command. In this example, we have invoke expression, and we also have new object as our commands. So we go into the command menu, we have ticks or splatting. 1 or 2, and so we'll choose. I was going to ask the audience which one they wanted to choose, but it's kind of hard with a pre-recorded demo to do that. So we chose 2. Now we are doing splatting on both of those commands, and they are randomly concatenated. So next, net.webclient, which is an argument. We'll go into the argument menu. We have 3 options here. Which option? We'll go with 2 again. So now net.webclient has tick obfuscation. Download string, this is a member argument. So we go into the member menu. Again, options are in green. Choose whichever one we want. We'll go with 3. And that there's a small difference in how you have more options with PowerShell 3 and later for obfuscating members, but I made this tool to work, for the payload to work on PowerShell 2 or later. Because of that, when you want to treat a member as a string in PowerShell 2, you have to add a .invoke member. So sometimes you'll actually want to run member twice just to make sure you catch it. So there we ran it again and caught that invoke member with ticks. So now every token of this command has been obfuscated. We can copy it to clipboard, we can paste it into a PowerShell prompt, and it works. So from a defensive perspective, let's go and let's look at the event log. So let's look at PowerShell, and we'll actually see there's our script block log with all of the obfuscation intact. You'll notice a lot of warning level logs. It's because a lot of these techniques, PowerShell is already recognizing as suspicious, but not all of them. But are we looking for warning level logs in PowerShell, 4104 script block logs? Something we should probably start doing. So let's get rid of that obfuscation. That was kind of cumbersome to look for all the elements and choose each one. So we also have a nice all function. You can just hit one. It'll randomly choose the order of all those. And you can do it as many times as you want, and your command just gets bigger and bigger. That's one of the hopes of this tool, to show people how quickly commands can morph but still actually work. So that was token level obfuscation. We'll take a step back and look at string. We have our concatenate, reorder, reverse, which works just like we talked about in the presentation. I'm going to actually fast forward just a little bit to get to the more interesting stuff. We have encoding options, which again gives us our ASCII, hex, octal, binary, secure string, and they all work. Here's me just going through all these examples. Launcher. So here we have, again, all the launch techniques that most of the launch techniques that we talked about. I'm still adding a couple more in. But yeah, so we have environment variable or standard input, as well as, again, the ones that have ++ basically means we're going to push the arguments up to the grandparent process as opposed to just the parent process. And for any of these, you actually then have this menu for all the execution flags that you want to apply. And again, it'll randomly choose the order, the substring, the white space in between before it applies. And there's your prompt. One thing to keep in mind is after you apply a launcher, it's no longer just PowerShell. You've wrapped it with command or something else like that. So if you ever try to apply obfuscation after you've applied a launcher, it'll actually tell you, hey, like, you've already applied a launcher, you can't keep obfuscating, so you need to reset. So all these little fringe cases I've tried to handle in the tool with helpful prompts. But yeah, once the launcher is kind of the last thing you apply, because you're done obfuscating the PowerShell command, the PowerShell level, and you're wrapping it to actually launch it through some other means. So we'll copy this to clipboard. Go ahead and get out of PowerShell, copy it straight into command.exe, and it works. And again, if we go and check our command line arguments, we'll use sysmon, then we'll see that the PowerShell arguments don't contain the actual command. It contains, again, randomized invoke, randomized standard input or environment variable invocation syntax, and the actual command payload will be stored in the parent process. Fast forward just a little bit. This is applying one of the grandparent ones. We run that, it works. This video is online, or you can just download the tool and play with it that way. All right, so for the very last part, we're just doing kind of a rapid fire. We'll go ahead and reset obfuscation. With our original command, we'll go into token. We'll obfuscate all the tokens 1, 2, 3 times. We'll go back. Let's now look at string level obfuscation. We'll choose 3 to reverse the command. We'll go back. Let's then apply encoding level obfuscation. We'll choose hex. Test it. Still works. We'll go back. Let's go into launcher. Let's choose standard input ++. Got to move those arguments to the grandparent process. We choose our flags. Outputs the command. Copy it to clipboard. Paste it in the command prompt. And it works. It's pretty terrifying. So, as a blue teamer, this is kind of what I feel like often when I see this sort of stuff. But again, I don't do this to be cruel. I really hope that this is, I like to think an encouragement, but I'm not that optimistic. Like, I really hope that this knowledge transfer is helpful to defenders who are here, because attackers are already obfuscating. We can't think they're not. Jeffrey Snover at a keynote at DerbyCon basically talked about the difference between real security and ignorance fueled, or hope fueled by ignorance. I really hope that this talk shatters your hope like it does mine, so that we stop relying on ignorance that it's really as simple as we think it is, because it's not. And it's possible to be much more complicated, and attackers are aware of that. They're already using small pieces of this. So I really hope that this research and this tool enables all of the defenders here to make testing of your detection easier, so that you don't have to spend the hundreds of hours that I have looking at all this stuff, but you can actually just take the results and start to look for how good are our detections, So again, a purely command line approach is extremely difficult. It is possible, but PowerShell logs are really where it's at. The PowerShell team from Microsoft has given us an amazing gift with these PowerShell logs, with script block, module, and transcription logging. In the earlier slide, my colleague Matt Dunley has put together an excellent blog post outlining all these things, something good to look at. What about Python or VBA? Like, how good are their logs? Right, they don't exist. Like, again, PowerShell has given us logging, period. Like, how crazy is that? We should be so thankful. And lastly, we should break our assumptions of what we think is possible. We should know our options from a language perspective as well as from an obfuscation perspective of what is possible, and hunt not just for known bad, but also for indicators of obfuscation. So this is my talk. I just want to say thank you to the great people that I get to work with on a daily basis, as well as previous colleagues, and really most importantly, my wife. She's really encouraged me in the past year and let me do this research, and without her, I wouldn't be here. And she humors me by listening to me talk about PowerShell a lot. And so any questions, I'll be in the speaker's corner. Again, I'm here all day. Please, I feel like I'm pretty easy to find around here, so please just stop me. I'd love to hear your thoughts about PowerShell and criticisms and anything like that. And I really, please hit me up on Twitter. I'd love to stay in touch and be a resource as best I can to help us as a blue team be successful going forward. Thank you very much.